Okay, hi everybody. So today I'm going to talk about inflammatory immune responses and basically what occurs in an inflammatory immune response. So this up here is my blood vessel. These down here are just cells and of an organ of some type. And this here is a bacteria. So let's say this is a gram-negative bacteria. And let's say our gram-negative bacteria produces an endotoxin. All right, and our endotoxin goes down here to these cells that are right here. And let's say they destroy the cell membrane here, or they damage the cell membrane here. All right? Now, here's what's going to happen. And again, this is our endotoxin. Here's what's going to happen. You actually have an enzyme, and what it's going to do is it's going to convert the phospholipids that are here into arachidonic acid. So it's going to convert this into arachidonic acid. All right, and you may have heard of the term arachidonic acid before because it's actually found in red meat. So then what's going to happen is some other enzymes are going to convert this arachidonic acid into what we call prostaglandins, and also into something else that we call leukotrienes. Okay? Now, the other thing that could happen with this endotoxin is floating around in here, we can have something called a mast cell, which is a type of white blood cell. So here's my mast cell right here. And it has little receptors that are on it. Okay? So it has little receptors on it. And let's say that our endotoxin, as it's being released, happens to get into a receptor here on the mast cell. So this is my mast cell. And the mast cell can also produce chemicals also. It can produce prostaglandins and it can produce leukotrienes. So let's go like this, prostaglandins. And leukotrienes. But the other thing that it may produce, or it does produce, is called histamine. And if you've ever had an allergic reaction, you've probably heard of histamines or antihistamines to basically stop these from being released. So here's what's going to happen, is the leukotrienes and the prostaglandins, what they can do is these are my endothelial cells that are in a blood vessel. On the bottom of the endothelial cells, we have receptors. I'm just going to be drawing them in a few spots right here, but realize these go the whole way along blood vessels. So we have receptors here. All right. I'm just going to draw 3. And here's what can happen, is these can go up and bond with these receptors, okay, and these here too, can go and bond with all these receptors, okay? So what's gonna happen when that occurs? Well, first of all, you have proteins that are on the inside of here, and it's going to change, or it's gonna make the proteins kind of present themselves almost like another type of receptor. So I have receptors here and I have receptors here. Okay, and again, this is going to be the whole way down. We're going to talk about these again in just a little bit. But because this is attaching to the receptors here, it's going to do a few things. One of the things it's going to do is it is going to cause the muscles that are within this blood vessel to relax. And when they relax, the blood vessel is going to get bigger. Okay, so what I'm going to do is, this is the width of my blood vessel right now. I'm just going to draw this up here just to show that my blood vessel has gotten bigger. So because my blood vessel has gotten bigger, this is called vasodilation. So we're going to have vasodilation going on. And when you get vasodilation, what's going to happen is we are going to have more blood coming to the area. So just to reiterate, these are going to bind with these receptors along this blood vessel, and again, I only drew in 3 areas, I could go this whole area, that's going to cause the receptors to come out, and it's going to cause vasodilation. Vasodilation is going to lead to more blood coming to the area. Now, the other thing that it's going to do is on the inside of this, remember, we have something called plasma, which is the liquid part of blood. That's the liquid part of blood. When these combine to these receptors, what they're going to do is they are going to cause the endothelial cells to contract. They're going to cause these endothelial cells to contract. And when the endothelial cells contract, what's going to happen is it's going to leave more space in here. Okay, the space is going to open up in here. All right, now, because we have more space in here now, and again, I'm only doing this area here, this could go along this whole blood vessel, but because we have more space in there now, what's going to happen is 2 different things. First of all, plasma is going to start coming out, okay? But don't forget, we have vasodilation, so I'm getting more blood and therefore more plasma in the area. As the plasma comes out, it's going to separate this space that's here between the blood vessel and these cells here of whatever organ this is. And because that starts to increase in size and I'm getting more fluid, that is called edema. So I get swelling. Now, the other thing that's happening is, once again, as this spreads out, I get more blood coming to the area. Blood is red. So because I have more blood coming to the area, I am going to have redness that's going to be occurring too. The other thing that's going to be happening is because of the fact that the blood is warm and I get more of it coming to the area, it's going to make this area warmer. So this is also going to become warmer, or I'm going to have a temperature increase. Okay, so there's 3 things so far that can happen. Okay, once again, we have this, the endotoxin either damages the membrane and causes the release of arachidonic acid, and then due to enzymes, right, our phospholipids here are converted to arachidonic acid. 2 other enzymes will then convert these into either leukotrienes or prostaglandins, or if the endotoxin goes to the mast cells, I'm going to end up with histamines, leukotrienes, and prostaglandins. All of these will go up here and bond to receptors, which will cause other receptors to basically pop out. We're going to talk about those right now. However, like we said, when it bonds to those, this causes vasodilation, more blood comes to the area, and it also causes contraction of my endothelial cells. And with the contraction of the endothelial cells and the extra blood, I'm getting plasma leaking out. That leads to edema, redness, and it makes the area more warm. I'm just going to move this down here real quick. And let's take a look at what's happening here with these receptors. So I have these receptors now up on top of here. All right? And in the bloodstream, because don't forget, like we said, with vasodilation, I'm starting to get more blood coming, more red blood cells, but I'm also getting more white blood cells. So inside the bloodstream, I am going to have macrophages, and I am going to have something else called a neutrophil. And these actually have sugars on the bottom that are going to kind of fit in with these receptors. Okay, so basically as these are coming by, the receptors are going to stop. They're going to stop these they're going to stop those white blood cells, and basically it's going to cause them to leave from inside the bloodstream. So my macrophages and my neutrophils are going to come. They're going to hit these receptors. The receptors are eventually going to cause these to come out into this area in here, right? Don't forget, I still have plasma coming out through there too. All right, so let's just say they're going to come out into this area here. So now here's my macrophage. It's outside the bloodstream now. Here's my neutrophil, also outside the bloodstream. And then what happens is these now will basically go over and tell these, hey, you need to come over here and to get this guy, to get my bacteria that was down over here. Okay, so these are going to come out and now they're going to head over that way to get that bacteria. The other thing that's going to happen is the macrophages are also going to release some chemicals. And what these chemicals are going to do is they are going to go to the hypothalamus and they are going to cause a fever. So now what we have, and actually my neutrophils will do this too. And now what we have happening here is I've explained the edema, right? Because of these being released due to the endotoxin. Let me go over this way real quick. So because of these being released due to the endotoxin, or due to the endotoxin, these are going to be released. This is going to be released. An enzyme is going to convert this to these. They're going to bind with my blood vessel. And then once they bind with the blood vessel, what they are going to do is they are going to cause vasodilation, right? It's going to bring more blood to the area. It's also going to cause these receptors to pop up, right? But it's going to bring more blood to the area. Plasma is going to leak out, right? And the plasma leaks out, causing edema, redness, and it makes the area warmer. Now, we also have the receptors that we talked about. And again, I drew receptors here and I drew receptors here, but technically they'd be all along this blood vessel because we have the problem going on in here. And we want to stop these white blood cells so they can come out and take care of it, right? So now what's going to happen is those are going to come out. They're going to go back over to where my bacteria is right here. And then what they're going to do is they're going to phagocytize it. There's one more thing I want to talk about that I forgot. On these cells down here, we have receptors that are called nociceptors. Nociceptors, nociceptors. These are responsible for feeling pain. So as I get my edema and this starts to increase in size, eventually the edema will start putting pressure on these nociceptors. And when they do that, that is going to cause pain. Okay, and that is the inflammatory reaction that we have going on. So I hope you enjoyed the video.